My name is Mohammed Berehi. I'm a PhD student in the group of Professor Tobias Kippenberg at EPFL in the Laboratory of Photonics and Quantum Measurements. And today I want to ask you a question and see if we can come up with an answer for this and see if we can have suggestions for this. So the question is, how do you document and share the tacit knowledge of micro and nano fabrication? And in order to give you more clarification of what I mean by that, let's consider a case of starting a process flow in the clean room and trying to develop a process flow. We usually start with an idea. We write in a piece of paper the steps that we're going to do. But usually we start with the first run, with the first wafer. We call it here device 1. And we do a lot of iterations and some things happen here. Oops. And at the end we reach to a device number 20, something that gives us the performance that we wanted, something that we wish to start with. But the question is, what really happens here in that ... part? What are we doing really? And to be more clear, let's try to open this part. So what we do, we usually start with the first run, first wafer. We have an idea, we start with it, but it never works the first time, right? We most probably have some sort of a contamination in some step, and in order to fix it, we do some search and try to look into literature, ask people who are more senior in the clean rooms, they have already tried it, and we try to fix it. After that, maybe we're doing an alignment to our first layer. There is also a kind of a different layer of lithography. We're going to have an alignment issue. And then again, we need to search and test again. And maybe we do some etching and we have some contamination or some issues. Or we do some thin film deposition based on the project, based on the design. And after all this, we get to a device number 2. And in reality, we usually don't stop here, right? We maybe continue doing this for another 19 times, right? To get to the performance that we want, which means that we're going to go through all these steps 19 times, and we're going to generate a lot of information. And usually in publications and in thesis, there's kind of a gap here. People only talk about this, how great their idea is and how great the device number 20 is, how the device number 20 is made. But what people really don't talk about is what really happens in this loop, right? What's really the case here? We don't talk about these 19 times of all these tests. And these things are a lot of information. So now let's think about why we have this problem, why people don't talk about this. And one of the main reasons, if you ask people who are doing fabrication, usually they say, okay, if I write them in my notes, I usually write them in my own notebook, but they're not searchable. They're not searchable for everyone. And another point, another issue here is that people usually don't want to spend a lot of time here for writing something that is not going to be in maybe a publication, that it's not going to get them the kind of the credit that they want. And maybe somebody wants to write these iterations for a journal, but usually journals have a lot of style guides, and that's going to be a problem because you don't want to spend a lot of time on some tests that you did to write them in a nice format with lots of figures and things that are appealing for the journals. And at the end, one more issue is that nobody really gives credit for citations in a lab note because, yeah, it's not accessible to everyone. And in a nutshell, we can say that they don't have, for example, a DOI, or they're not somewhere that people can find them and therefore cite them. They're usually in a lab note of a PhD student or a master's student or a student doing an internship or a project for a couple of months. So here, that's the problem. Here, that's kind of the gap that I wanted to tell you about, and I wanted to establish that here there is a gap. There is something missing. But what if we could consider that scientists in different corners of the world, what if there was a platform, there was a system where we could write down our notes, very simple, a few lines of text, a few images, SEM, optical image, AFM, topography measurements, everything, just a few images that, for example, we looked into when we were, if you remember, iterating in the process of getting from start to device number 20. And we could really get credit for it. We could receive a DOI for it. What if everything was somewhere on the web, which it could be searched through, and everything was on a reliable server, not, for example, in a commercialized server? What if everything was open access, so everybody with internet connection could have the possibility of using these notes and finding their questions? And another point that would be nice to have, which comes really into the idea of collaboration and the collaborative aspect of our project and this platform, would be to be able to communicate, because something that might be missing in scientific journals is that there's a paper, you read the abstract, you're interested, you read the paper, but if you have some questions about them or maybe some suggestions to the people who are doing the experiment, you should, for example, write an email to the authors, and this maybe get lost in the full mailbox of the author, right? So what if there was kind of a commenting section, kind of a way, kind of a place which you could comment and ask your questions from the authors, for example, giving them a suggestion, or like, for example, asking a question like a detail, or, for example, if you have tried the same experiment and you got a different result, or a result which is the same, maybe you want to kind of communicate to them and let them know, and this way maybe open the way for collaborations. So this is the idea of Nanofab-net, which I would like to present to you today. We're trying to put together notes, documents in written format. We're trying to give them credit. Therefore, we give a digital object identifier, a DOI, which is unique for your own work and can be cited. Therefore, if you come up with an idea first, if you come up with a test, for example, to improve your etching, to improve your lithography, or in general fabrication process, for example, if you're in a company and you're working on a tool, you're an R&D engineer on a tool, and, for example, there are some good practices to get the best results from your tool. Maybe you want to put them for everyone, for all the users of your tool. Therefore, show them how you can get better performances from your tools. And also making them searchable. So by tagging your articles based on the material you use in your, for example, test, in your machine, or the process that you do, they can be searched through. And everything is on an open access server, which we're collaborating with Zenodo, which is an open access server here in Switzerland. And everything is going to be accessible for everyone with an internet access. Therefore, no kind of subscription fees and so on. And also, we're integrating our platform with an interactive commenting section. Therefore, if you have a report, if you have a fabrication discovery, and some tests or some adventures that you did in the clean room, people can talk about this to you and can ask questions, or they can give you a suggestion, for example. So I presented to you the general idea of Nanofab-net, nanofabnet.org. That's the platform that we put together, and the idea of this platform and our motto is to publishing the unpublished and publishing the tacit knowledge, which always is generated through the clean room, the trial and error nature of the work in the clean room. And we're trying to make it very, very easy to publish and to share, let's say, your discoveries. and therefore use the time that you have spent in the clean room and give you credit for it. Our project is an open science from an open science initiative of EPFL in 2019, and as I said in the beginning of my presentation, we're located in LPQM lab at EPFL, and we have a collaboration with Center of Micro and Nanotechnology at EPFL CMI, and all the data that is generated on our platform, everything is kept on an open access server, which for the safety of the users and for the safety of the people who are trusting the platform to put their knowledge there.